Hi, welcome to another video and episode of the BeagleBoard in combination with the fischertechnik rubber interface and my monorail with propelled motor and carriage. Last time I tried to figure out if the output I got was reasonably fitted to the 1 second stay. I didn't quite figure that out, so when I start the program, the whole distance here, you can see that the carriage is staying close to the sonar, and I will remove it manually, and then all of a sudden it starts moving. So that is still a bit crazy, and I have not figured out why exactly that may be. Now there's something odd happening, because it says greater than 5 being 11. However, the carriage is very close to the sonar, so this output makes no sense at all. Let me... Okay, I have to put it a little bit down, and then it goes. Now it's at the light end and back at the sonar, so there is some nice response. Now it's at the light end again, which you see, I hope. But still, let me say, now it arrives 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, male catch, and that will say 14 seconds at the side of the sonar, with output that indicates it's at the side of the light. So that doesn't make sense at all. 1, 2, that more or less comes true at the side of the light. So then why does it stay at the end of the sonar for such a long time? If you see here, last time I actually put the sleeper to 0.25, which is a quarter of a second. Well, I can tell you this is not a quarter of a second. Much longer. So let's see what happens if I change this back to 1. I'm curious what actually will happen. So let's run it again. And see what happens. Something that does happen is that the propeller keeps running after it arrives there. So for instance here it keeps running for at least a second before it turns the direction. And that's odd as well. And the direction it takes, now the old direction of the propeller takes, in case of the sonar, at least 2 seconds. So 1, 2, 3, yes, 1, 2, yeah, so it's very curious why that happens. And here in the in this output that shouldn't be happening at all. 1, 2, 1, 2, 3, and there it changed direction. So time to think about this and figure out how to change it, because it is very odd. An odd thing is that if you look here, it says 4 centimeters, which is at the sonar side. So when I look at the carriage, the minimal working distance that it can send something is 2 centimeters. Within 2 centimeters it can't measure anything, and the resolution is 1 centimeter. So say 2, 3, 4, 5, 6 centimeters, that's what it is. Anything in between 5 and 6 or 3 and 4 it simply can't measure. So with this knowledge, I actually should have it stop at 2 centimeters and then see what happens in distance. Also, when I look at the physical thing, I wonder what it actually senses. Does it sense the carriage? Does it sense the power connectors? Does it sense the motor? All they are all part of the carriage, but not at the same distance. The carriage is about 2 centimeters longer than the motor. So that makes me wonder if that has something to do with it. Oh, and if you look at here, it says 3, and here also 3, and here again 4. So I guess it's time to take the camera and see what actually may happen if I change something. So now we're looking at the carriage. You see that it here stays a lot longer, and now you count 1, 2, it reverses, 1, 2, 3, and now it reverses, so it's 1 second longer. But also looking here, and let me stop the carriage for a moment, you can clearly see that here starts the carriage. This is the power connector, and this is the motor itself. And with the sonar here, let's say 2 centimeters. What is 2 centimeters anyway? I don't have a ruler here. Yes, I do. Rather old one, but it suffices for now. So this says 8 centimeters. Is that correct? About that. And then 2 centimeters is this distance. So if I take, so this is the minimum distance to anything of the object. And if I put it here, it may run better, maybe. Like this it won't run at all, or hardly. This runs better, and this runs probably good as well. However, with this 2 centimeters, what will happen? The cone is 3D, so let me put it here. The cone is 3D, so it senses here and it senses here in some 30-degree angle. So with this, it should sense this at all, and immediately. And the code says, as you've seen, larger than 5 or shorter than 5. So it has time to respond, and yet it goes completely back to the sonar. Does that make sense? No. Let me run a program again. So with the ruler at, let me try to figure out, actually this is actually 5 centimeters, so that means that it should stop here. At this distance from the sonar it should stop. Well, you can clearly see it runs, and then for another 3 centimeters, 3 seconds it keeps running. So something is really off. If I change the 5 to another figure, let's say 7. So larger than 7 and smaller and equal to 7. What will happen then? Just testing. One, 2, 3. Here I go. 1, 2, 3, 4. 1, 2, 3, 4, 5, go. 1, 2, 3, 4, 5. One, 2, 3, 4. Okay, that's a little bit off then, but that's perhaps some wiring issue. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. And it keeps hanging here. But here, now at the light's end, it's a very quick turnaround now. 1, 2, 3. Well, not that quick, but varies. But this is odd, very odd. So what to do about it? So what I will do is take this and put this right here. Or should I put it right here? Let me measure the distance. This is 1, 2, 3, 4 centimeters. Let me check what will happen then. One, two, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. 1, 2. 1, 2, 3, 4. Still not correct. Far from correct. Alright, let's change it to here, 1 centimeter closer. One, 2, 3, 4, 5, 6, 7, 8. Ooh, this is wrong. Probably because it measures this thing, but it still goes that way. So perhaps I should. Does it even measure that holding thing? I remove it for now. Perhaps best if I keep it removed. And I hold it with my hand here. Maybe minimal distance, minimal object location, but one, 2, 3, 4, say 3.5 seconds. 1, 2, 3, 4, yeah, 3.5. Roughly made. I should have it measured by the computer. Much reliable, much more reliable. But still, the turnaround time is lousy. Totally lousy at the sonar's end. Makes no sense at all. Then again, how to change it? Let me set it back to 5 centimeters. because the 7 didn't make any sense. That is somewhere here. 7 is somewhere here, and that makes absolutely no sense in this case. It just goes on. And now it says 3 again. So there's something to investigate. But how do I investigate this? As yet, not really sure. So, with a stop somewhere at 2 centimeters, 3 centimeters, or 4 centimeters, it doesn't matter at all. Changing this to 7, which is of course 7 centimeters, had no effect either. And now it has a nice turnaround, although still with 1, 2, 3, 4 seconds about before turnaround, which means that the propeller starts running the other direction. And well, here it says 3. That this says 13 or even 14. That's okay with me. It probably is. But why does this say 3? Does it measure it quick enough? That is what I'm going to wonder. What I am wondering actually. Is it really actually fast enough? Because that would explain a lot. If it is too slow in detecting the distance, and then I have to keep the speed of the BeagleBoard in question, because how fast is the BeagleBoard? I think that is a very nice question as well. With that said, let me open a new shell and -I CPU. dmessage is the command to request all hardware data. Grep is a Unix command by which you filter patterns out of files. Everything in Unix is a file, and with this command you filter for CPU in either capital or small print from the dmessage command. So the BeagleBoard runs on an ARM version 7 processor. Which is very interesting, but I want to know the clock speed. And unfortunately I can't figure it out from this output, but I think it's somewhere around 750 megahertz. So with that, it but then again, that should be fast enough to handle this. So does that work out? I'm not quite sure. I just hope so. But in the meantime, it's interesting enough to find out the relationship distance and the measuring speed of the sonar, and see if that can change with the propeller turnaround time. With that, I conclude this episode. Thank you for watching, and certainly to be continued.